Hi, in this recording, I will talk more about direct current circuits. What we're going to do, what we did before was different. Like, we have very simple circuits where I have only a resistor, a battery, a switch, that's it. Okay, today we will deal with and we will analyze circuits with multiple resistors. And we're gonna see how we are going to, analyze the circuit. We are going also to introduce how to use an ammeter, voltmeter, or any meter in a circuit, but we're gonna focus on these. And also we will include now rules in this discussion, rules that can apply, which are Kirchhoff's rules, which can apply to any circuit, but now with multiple loops. Now, something that is really, very important is that we are going to deal with direct currents. What is the direct current? It is a current that keeps its magnitude and direction. Then it will not change. Now, this is like, I will say, mainly this is what we are using for flashlight, the battery in your car. All these are direct currents. Now, when we move to household appliances, like your fridge, washer, dryer, whatever we have what is called alternating current. And that is going to be keep on changing magnitude and direction all the time. All right, and this is really what is, we need to pay attention. Now we will say the analysis and the principles that we are using, they're gonna apply to both types of circuits, but we will, now we are going just to introduce I will say DC circuits. Now, when we wire resistors in circuits, we have two types of connection. Resistors can be connected in series. And these, when I have let's say this is the first resistor, R1, this is R2, and this is R3, and they are connected to like one voltage source like this connection, we call it in series. These are really connected one after another. Now, if you look here, which is very important, the current in the circuit is going to be the same. All right, and what is going through R3 is the same R2, is the same R1. This is the only path for the current. Now, for the voltage here, that voltage is going to be distributed, okay, based on the values of the resistors. Then this is going to be V1, V2 plus V3. And that is going to be this one here. I will call that this is Ohm's law, from R, which is, I will call it equivalent. Equivalent means I'm going to remove all the resistors and put one resistor only. And this is I times R1 plus I R2 plus I R3. And since it is the same value and constant, then I can drop it from all. And then finally, when I have, let's say, three resistors of these are the values, I can actually replace them with a single resistor that having this value. You need to remember always that here we have the same current going through the circuits. Now, when we go here for resistors in the other connection, which is, we call it parallel, we're going to have here what is constant is the voltage. Then actually, let's say, assume this is R1 and this is R2 and then this is R3 and then this is the voltage. Then actually what is really constant is the voltage, but the current here is gonna branch, like when it's gonna come here is gonna be two branches. Then I might say I'm gonna call this R3, I'm gonna call this R2, I'm gonna call this R1, and then again here they're gonna gather together and they're gonna be the total current I will say here I equal I1 plus I2 plus I3. I have the same voltage, then this is V over R, V over R1 plus V over R2 plus V over R3. And from these, I know that this is the equivalent. Then I can say here 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3. Then this is how we are going to actually connect when we have in parallel. Now sometimes I will have a combination. Then we might have resistors connected in combination or combinations of series and parallel, and therefore I need to recognize what is the arrangement and work on it. For example, like if I have this setup, you can see here that these like this is R1, this is R2, this is R3. Then I will say here first R2 and R3 are in parallel, and then I will find their equivalent. I will say 2, 3. It is 1 over R2 plus 1 over R3. And then when I will find, after I calculate this one, I can say R equivalent is going to be R1 plus R2, 3. And I can replace in my circuit just with that resistor. Okay, I will okay, I'm gonna see you in another video in a little bit. Thank you.